So right now we are considering first model, special stiffness and stability of the building, and right now we are considering the term geometric stability. It's a property of a system whose shape can be changed only to the deformation of its elements. And as Elizabeth helped me, the difference between a rigid connection and hinged connection, in this case, that this connection work as the geometrically stable construction, and the deformation of its of overall system can be because of deformation of each element. But and when we consider a hinged connection between the elements, in this case there is no deformation of column or beam. There is only deformation because of the connection of the building. But nevertheless, we still using hinge connection in structural elements. But how we can use hinge connection to make it geometrically stable? So it is possibility to make it triangle, because when we are talking about triangle elements, in this case we can get the geometrically stable system which can be not which will not get deformation because of its nodes, but only because of its elements. And when we are getting adding such additional link element which connects these nodes, even hinged connection between elements will give the ability to work this structure as geometrically stable structure. So nevertheless, we can also make geometrically stable triangle, and the difference between left triangle and right triangle is not significant, and it will be it will both of them, they will work almost in the same way. There will be not significant difference because these elements will get a little bending moments, but these elements can work only on tension or compression. There will be no any bending moments, maybe a little bending moments because of the eccentric pressure, but it's not the bending moments like in this connection, in this rigid connection between the elements. So when we are talking about multi-span structure, we have also taken into account the uh, understanding of special stiffness. So, and in this case, when we're talking about rectangular section, here we can see how it works. So this is two triangle, this is four triangle, and one triangle. All of them are rigid, geometrically stable system. But when we're considering this connection, rigid connection of elements, we can also see the geometrically stable system. When we are designing a multi-story building or multi-span building, we have to know that the stability of multi-span structure can be guaranteed by uh, only one link element which transform a geometrically unstable system in geometrically stable. In regular practice, we will not add only one link element mm, uh, per one direction of building. Regular solution of such a problem is to add a link element from this part and from this part. But from calculational point of view, from the point of view of geometric stability, it is enough to add one element in this direction. It's really important from the point of view of symmetry of this building to add additional link in this way. But nevertheless, this is enough. One is enough. Also, we have to add one link element in this direction, in rectangular direction to the first one, and also we have to add additional link elements in the in each floor to make the slab of the building also work as one rigid element, and we can make it by adding additional link elements. So, and how can we implement it all in a real project in real life? So first of all, when we are considering steel frames, it is also possible to make the design of such building to make it both in rigid connection in with rigid method or with link method. So, for example, in this direction, in this transverse direction, it's not a good solution to add a link element, because if we will add a link element, for example, between this corner and this base, or in this direction, it will destroy for example, the technological process inside of this building, because when in the middle of the building you will get such links, it will prevent movement of the transport inside of this building, or a crane or something like that, which can be located along this building. So that is why for this building was used a rigid connection between column and beam, and it is a rigid connection method. And when we are considering rectangular direction, in this way they have added links. You can see this link over here. So in this direction, it is rigid connection. In this direction, in the opposite direction, we will get link connection. And here, how rigid connection can be performed. So a lot of bolts or a lot of welding have to be done to make these connections from separate element to work as one common solution. And it's not a cheap method. So this method of connection is really expensive. So, and some examples. So same situation. In this direction, you can see these special triangle elements, which adds rigidity to connection of these elements of column and beam, and this makes it work like as a frame in this direction. In this direction along the building, they have added these crosswise arranged links, and it, as I told you previously, it is enough to add one link in one direction. In this case, this made for symmetry. When we're considering this building, you can see how big section of this beam and the connection between this beam and this column. So that make us understand that in this direction along this beam they have made the rigid connection, and along the building they have added, you can see these links. So it's a mixture of frame method with rigid connection of the elements and a link method. And it was when we were considering steel frame. But one more time, when we are working with a steel frame, it is really important to understand that steel buildings can be erected with both link and frame method of connection between elements, which gives us geometrically stable system. When we are considering, for example, reinforced concrete, it is also possible to make rigid connection between column and beam, or column and the slab, but it is easier to make this link element, but it's not a diagonal steel rod. It's much easier in reinforced concrete building to make reinforced concrete wall which will serve as a link. And for example, sometimes it is possible to make the mixture of this method. So, for example, on the first floor of such a big building, to make big spans, they have designed metal frames which serve as a big frame for the longitudinal direction of this building. Also, this frame serves as a mm, as a beam, uh, not not a redistribution beam. It's like a transfer beam. Transfer beam. It serves like a transfer beam for the upper floor. So you can see that these columns in very small with a very small span allocated here, but here we can get the open space, which give us an opportunity to make any time of public building, public area on the ground floor of this building. Also, when we are considering this reinforced concrete building, it is also possible to make it in frame method. So both link and frame can be used for reinforced, but as I think it is easier to make it in link method, the connection between horizontal and vertical elements. But the only one option that we have, no, when we're talking about the masonry buildings, we don't have any option. We have only one link method for such a building. But in masonry building, you will not find steel diagonal rods. You will find only brick walls, and those brick or masonry walls serves as links along both of the both directions of the building. So that makes us possible to consider this table as this. So when we're talking about the steel frame, we can use all methods. We can use link frame and combined frame link method. But easier for steel construction to make it in a link method. When we're talking about reinforced concrete frame, we can also use all three methods: link method, and for multi-story building, it is easier to make it with the link method. We can use frame method, and the frame method is most widely used for non-seismic regions, for for the buildings with a low amount of floors, for like 3, 4, 5 floors. In Odessa, it's 3, 4, no, not more than 4 floors. But in Kiev, it may be a bigger amount of floors because there is no seismic impacts in Kiev. But such buildings with amount of 3, 4, 5 floors can be erected with the frame method, and it's really easy to erect. For multi-story building, it is easier to make a geometrically stable system with the link method. And also we can use the combination of frame and link. It will give the geometric stability of by using these two methods. And when we're talking about load-bearing walls, from masonry or bricks, the best and the only one solution it is to use a link method. And final part of this lecture will be devoted to the expansion joints. It is the most widely seen mistake in your diploma's papers, and a lot of real life projects, concepts, designs developed by architects has this significant lack. They trying to forget to not think about expansion joints, and I will explain you the difference between four main expansion joints which you will meet in every big construction. So, first of all, we will consider the thermal expansion joints. Why do we have to take into account thermal expansion joints? Because all of us know that all elements, when we are considering impact of the temperature, it can be extended by the warm weather, and when we will locate it in the fridge or refrigerator, it will get contraction. Yeah, so heating, extension, cooling down, it will lead to the contraction of the element. And when we're talking about something like this, it's 31 centimeter length, you will not see significant deformation. But when we are talking about the building with the length like 100 meters, this contraction or extension will take like 5 even more centimeters, and such a big deformation because of temperature will lead to significant cracks or even destruction of parts of the building. So prevent building for such type of deformation, we have to cut it down. And the main important question about the expansions, the joints that you have to know, that if you will forget about the expansion joint, real life will add it to your building. But if you are designing expansion joint, you know where you will get those deformation. But if you will forget about the expansion joint, the life will make this expansion joint in the worst place for you. You have to know and you have to remember that. So that is why we have to make the simplest solution for thermal expansion joints is to make double columns, and these double columns will solve the problem of the thermal deformations. Because if we will make, for example, every 40 for some structural systems 60 meters, every 40 60 meters such down columns, it will protect us from significant deformation. Yeah, our building on these 40 or 60 meters will get some horizontal deformation, but those deformations will not be so critical for our building. It will not destroy load-bearing elements, or it will not lead to significant cracks in non-load-bearing elements. So thermal joints provide building from the ground level to the highest part of the building on parts which give ability to make the horizontal deformation of the building without significant cracks and deformation. Second type, so how it looks in real life. So it is this column belongs to this part of the building, and right column belongs to this part of the building, and between them there is a small expansion joints. Here how it looks in structural and the computational model uh, for 3D three-dimensional calculation of the building. So two columns and the slab divided with the expansion joint. Another type of joints that we will also consider today called settlement joint. Settlement joints, it is the joint which divide building not from the level of the ground, but it shall divide also the foundation. Why is that so? It is really important from another point of view. Settlement joints, we have to make settlement joints in the place when we have uh, various amount of stories. For example, if we will design a residential complex with 5 stories building near this 7 or 12 stories building, I have my project. I'm not proud of it. It's a situation, but nevertheless, in Luzanovka we have one masonry complex which has an amount of floors from 8 till 20, and if you will look closer, you will see the expansion joints between the 8-story building and 20-story building. Why do we need to make these joints? Because various amount of floors gives various pressure on the ground, and it's clear when we have big amount of floors we will get the bigger deformation of soil, and when we have a lower amount of floors, we will get also deformation, but this deformation from the multi-story building will be much bigger compared to this one. So if we will not split this building on two parts, this uneven deformation will lead to vertical crack between the parts with an even amount of floors. If we will take this into account from very beginning, we will split this building on two parts, multi-story and low-story building, and they will work as separate like railroad wagons, and it will protect our building from vertical cracks. Main difference between thermal joint and settlement joint is next. Thermal joints are not dividing the foundation on the parts, because we know that underground, like 3 meters or even less, we have a constant temperature. It's like 20 to 12, sorry, to 12 degrees all around the year. So that is why when we have constant temperature, we will not get those significant deformations. So there is no need to cut the foundation on parts. But when we are talking about settlement joints, we have also to split on parts and foundation, because the foundation will get uneven deformation. In if we will not split it, it will lead to the significant cracks and deformations. So we have already considered two expansion joints. The third one is the shrinkage joint. Shrinkage joint, усадковий шов. Тобто, що мається на увазі? Such type of joints is used in cast in situ concrete, in cast in situ floors, because shrinkage, after you have poured the concrete, shrinkage leads to cracks inside of it. And if you will not split it with the joints, the crack will split it instead of you. I think that when you were attending big malls like Epicenter or City Center, you have seen the joints in the floor. So those joints that you have seen in the mall at the malls, those are shrinkage joints, and those joints protects floor from cracks. For example, if you will visit my building that I have designed, Ostrov Trade Center Ostrov. So on the upper floors, you will see the tiles that they have used to cover the floor have significant cracks, and those cracks are because the contractor decided not to split the floor with the shrinkage joints, and they decided not to do it. So real life made those cracks, and you will find those cracks in the underground part of the building. You will find these cracks in the upper floors of the building. So we have considered already three types of joints, and the final one, anti-seismic joint, the joint which you have to do in at the seismic regions. When you are designing the buildings with big length, so you have to split the parts of the building with the joint. When you are designing with the building with a non-even amount of floors, and if we are designing, if we have to make thermal joints, for the temperature deformation of the building. For when we are considering seismic joints, we are designing seismic joints to protect the building from pounding effect. When one part of the building kicks another one during the earthquake, it will look like this. So here are two buildings, and sometimes during the earthquake you can get this effect. And to protect the building from this effect, we can locate building as far as we can do it according to the building codes. It's like 5 centimeters between single-story building and more. With so as higher you design building, the wide expensive anti-seismic expansion joint you will get. So the main idea of anti-seismic expansion joints is to protect building from such pounding effect when one part of the building, one section of the building kicks another one. So here is the main idea of anti-seismic joints. So, and how those expansion joints looks in real life. They can be performed by using all of such type of solution, and this solution provides the ability to get the horizontal deformation or vertical deformation. You can see if there will be some horizontal deformation, the the movement inside of this joint will be this way. If you will get the vertical deformation, it will lead to such kind of deformation, but we will not see the crack inside of it. Also, we have such solution. It's a vertical anti-seismic joint between parts of the building. So here are the solution of expansion joints which we and which you can use in your practice life. This solution can be used both for the temperature and settlement joints. This only for the temperature, because you see there is only one direction of movement because of the deformations. This solution can also be used for the shrinkage joint. So that's all for today. So I will remind you. So this lecture was devoted to the special stiffness, special stability, and geometric stability, and all these all these questions are about the main and important part of our real design practice. It's to guarantee the stability of the building so it's the ability of building to maintain its original position or shape. So position or shape. So that make us understanding that we have two possible loss of stability of the position, and loss of the of stability of form. So we can provide both of them to the building which we are designing. Also, we have analyzed the geometric stability, and we came to the conclusion that we have two ways to provide geometric stability to our building. It's a frame method or link method. Frame method, it's a rigid connection of beam, and when we're talking about link method, it can be used for the hinged connection connected elements, but like this diagonal rod. Also, we have analyzed the ways how can we make it in real life. And when we're talking about in steel frames, we can use all three methods: link, framed, or combined frame link method. When we're talking about reinforced concrete, also three of them can be used. And when we're talking about masonry building, we have only one method, which is called link method. There is no possibility to make rigid connection between masonry wall and reinforced concrete slab. And also we have considered four types of expansion joints between parts of the buildings or between separate buildings. It's thermal, which protects from thermal deformation and thermal rupture of walls, columns, beams, etc. Settlement joints, which serves to protect the building from uneven deformation, cracks. Shrinkage in cast in situ concrete elements or cast in situ floors, and anti-seismic joints, which serves to protect the parts of the building or a different building from pounding effects. So that serves for protection of the mutual impact of parts of the building on each other during the earthquake. So that's all for today. Any question? So thank you for your attention. See you in 2 weeks on lectures. See you next week on practice. And I will also download this video to YouTube. Thank you very much. See you next time. Bye.